Reference RH talks about two special subject relationships that happen fairly infrequently, but yet at the same time, they're very powerful relationships. I don't require them in this class. However, usually at least once every 2 or 3 years, I'll have a student that wants to do something along these lines. So I built this reference to give some guidance as to how you would build what's called a self relationship. There are two different kinds of self relationships. One that's called the recursive relationship, and the other one's called the couplet relationship. So, what do we mean by a self relationship? Well, unlike the other relationships where it's a subject that has a relationship to another subject, or a subject that has a sub subject, like when we had, in the case of a supplemental relationship, when we had uh, a contact and their phones, a self relationship is a single subject that has a relationship to itself. I know that sounds really weird, but really what happens is there's a relationship among the records that are stored in a single subject. The primary example of that would be things like if I had a table that had my employees in it. One of the fields that I might have for the employees would be the supervisor of the employee. But guess what? The supervisor of the employee is also an employee that has its own records in the same table, its own record in the same table. So how do we deal with that when we have a subject where some of the records have relationship to other records in the same table? And we build what's called a self relationship. And there's two kinds. One that is basically a one to many, and another one that's a many to many. The one to many is the recursive relationship, and the many to many is called the couplet relationship. So let's start with the recursive relationship. And again, you'll notice that this reference looks a lot like the lessons that we use this semester. It's pretty much structured the same way. It has a lot of good information about the two different relationships that I'm going to talk about here. Um, for the recursive relationship, you could kind of think about it that what we want to do is create a hierarchy of records. In fact, you could have multiple hierarchies of records. But what we'll do is usually have a record that's value is used to link to another record, which is used to link to another record, and it could link out to multiple records. Basically, develop a tree of records, if you will. You can think of things like a genealogy, where you may have a member of your family and they have a mother and father who are also members of the family, and they'll have a mother and father that's also a member of the family. And so you would have a relationship to both the mother and to the father from a record, and then each of those would have a relationship to their mother and father in a record, and that would just keep going and branching out into basically a tree. That's why they call it a family tree. That's basically what a recursive relationship does. It allows you to build those kind of things. So I'm going to go right to the structure of it and show you how it typically is built. What you do is you build your subject table. So we'll have a table TBL employee. In there, I want a field that basically allows me to link to. Now, this is a case where we have an employee and we want to link to the supervisor's record. So I basically want to have what would typically be the foreign key of this table that I would dump into either a supplement or a junction table. I'm just going to dump it into this table and make it available for a supervisor. So, in other words, say this is my employee record. On there, what I want to do is I want to link in this field to my supervisor's record. And I do that by having a foreign key field that will take on the primary key value of the record that for my supervisor in here. Now that assumes that the supervisor's record is in here already. So there is an order of how you have to actually place records in here in order to be able to create this foreign key field and populate it. Now, if you come over here, you'll see another table. It's not another table. It's exactly the same table as this table. When you dump these into, when you drag the employee subject table over into the relationships window, you'll see TBL employee. If you drag it again, instead of putting a line that links like this, it'll actually put another, what looks like another instance of I'm sorry, let me step back here. When you drag in the subject table for employee, it'll look like this. When you drag it in again, it'll look like this. It's really the exact same table. It's not a new instance of it. It's not a copy of the table. It is exactly the same table. The only reason why Access does this is because, believe it or not, it can't make a line that goes from here to here. All right. You have to do this in order to establish this link. And so what we do is we just drag that table in there twice. We create the foreign key field. And to do that, just as we did on a reference relationship, you can come out here where it says single pick reference, take that, open it up, copy it. Again, I will give you these bowl objects when you do your final project. You'll have this object. You copy that in, you copy that, and then you open up this table, employees, and you drop it in there. And when you drop it in there, you'll see not only is it in there, but it's also in this one here. If you had already dropped these into the relationships window. Now, I would not suggest you do that until you actually have that field in here. But once you've got that field in here, now you can establish a relationship. And you only need to do it from one to the other. You don't need to do this going the other way like this, okay? Just do it like this. It's going to establish the relationship. So all you do is you drag your primary key value from the employee table onto that foreign key that's also in the employee table. And that creates the relationship. You set up the row source for the lookup for this, just like you did for a reference relationship or a supplement relationship. It's the same kind of thing. But you can see what's happening here. It says employee TBL employee underscore one is actually the very same table as TBL employee. I can't tell you how many times students get mixed up on this. They'll go out and actually make a copy of this table and make TBL employee underscore one. You don't need to do that. All you do is drop TBL employee in again, and it's basically setting a relationship from it to itself by doing this. I hope that's clear. So even though they are the same subject, Access shows them as two scheme instances of the same table. This makes the mechanics of establishing a soft one-to-many relationship type the same as those for the two tables. What we are doing is establishing a relationship between a subject and itself. So again, sounds pretty difficult, but it really isn't. All right. Now there's some things you need to watch out for. Okay. One thing is you really don't want to have a record where the employee is also the supervisor. In other words, say this is my record. You don't want to be able to pick me as the supervisor. Remember, this is going to pick values, all the values that are in this table, okay? And in doing that, it's if I'm in there already and then it populates this, it's going to show me as being one of the things that could be picked there, okay? Now, one thing you could do is put a criteria on the lookup query that doesn't allow it to show mine in the drop down list. That's not that easy to do. Okay, it's not really hard to do, but and it would be a really nice friendly way of doing this. But for sake, if you need to make one of these, a method you ought to do regardless is set the validation rule so that the employee record identifier supervisor, in other words, that foreign key field's value is not equal to the auth star dash rec identifier for that same record. Okay, if you set that and then you have this text that says the employee cannot also be his or her supervisor, then should they select the employee as the supervisor, it wouldn't let it save it anyway. All right, it would just say that's not allowed. An employee cannot be his own supervisor. Now, if you don't mind if the employees can be his own supervisor, fine. Then don't use that validation rule, and then you don't have to adjust the lookup either. Okay, but at the very least, set this. At best, go in and set the lookup query to constrain it to only be those values that are not equal to the record where the record identifier for the values in the lookup are not equal to this record identifier. That is another way to do it. Okay. Now, after you get that all done, you go back and you make your link. You go back to the database window, you make this link, you set your referential integrity, you put Cascade Update, as we always do. Never, and I really have to caution you on this, never turn the Cascade Delete records on for a recursive relationship. The reason this is called a recursive relationship is because one record impacts another record, that impacts another record, that impacts another record. So if you Cascade Delete, it not only gets rid of this record and the record it's in relation to, but that record, whatever that record is in relationship to, and whatever that record is in relationship to, it will take out your entire hierarchy from the point that you started the delete. And what it basically does is it prunes the tree of everything. Incredibly dangerous. So never put the Cascade Delete on this particular relationship. Okay, so now that's the case where I'm basically building, again, trees in here. Now, usually something has to be the first record when you have a tree, right? So how do you handle that? Well, an easy way to handle that is make this field not required. And in the root record, in other words, the guy who's at the top of the hierarchy or at the root of the hierarchy, just make it null for him. Make the value null. He doesn't have a supervisor. He's the head Fred. He or she's the head Fred. So you could think about a CEO. If you had the CEO and then everybody else in the company under it, so you have the CEO and the senior vice presidents and the vice presidents and the senior directors and the senior managers and the junior managers and all the way down to the employees and blah, 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 all the way down to guys like us. We would all have a supervisor, but that CEO, he has no boss. All right. One of the things I've seen people do in the past is make him his own boss. Well, again, if you don't put that validation rule, you could do that. Okay. But an easier way to know where a hierarchy begins is to make that null. Have that value null, which means you can't have this required, at least not up front. All right. Now, another thing you could do, obviously, which is really interesting, is you can have multiple hierarchies in the same table. Maybe I have multiple roots. In other words, I could have several records where that's the beginning of a certain tree of activity. So I may have several of these that have null in it. Okay, maybe I start my hierarchies based on the vice president. Okay, well, I've got several vice presidents. Okay, we'll say that they don't have a supervisor, even though usually there's a CEO or something like that. Let's say they don't. Okay, let's say they are the start of a new chain. We could have the supervisor of engineering. I'm sorry, the vice president of engineering, and then everybody reports them in a hierarchy underneath them. We have the vice president of quality, everybody, vice president of HR, everybody underneath them, vice president of operations, everybody underneath them. And they would basically all be at the same level. You could think about it as a level. Their records would be at the same level then, and they would all have null. Now, again, what if you wanted to require the supervisor? Okay, the way to handle that would be, before you set the field to require, create the record for the baseline people. All right. So let's just say we're doing one for the CEO. CEO doesn't have a supervisor. Before you set this to be is not null, create a record for the CEO, put it in there, and then come in and set this to be is not null. And then any record from that point on will require that you put a supervisor in there when you create the employee's record. That's how you would take care of that. Okay, so that's the recursive relationship. What about the couplet relationship? I sometimes call this the friends relationship. And this is one that you've all had actually exposure to in your lives. Okay, think about Facebook or one of the social media sites where you have friends, right? Okay, you as a friend could have many friends, and any one of your friends could have many friends. And yet you each have a record in some kind of table called customer or person or whatever, however they decide to build those friends, whatever they decide to build those friends from. So this is a case where you got a many to many of the same subject. In other words, a subject has a many to many relationship to itself. Let's see how that looks. Again, like all the other many to manys we did, it will have a junction table that will bring in the values sent from one employee record and the values sent from another employee record. And just like the recursive, when you drop in that employee relationship into the relationship window, you drop it in again and I'll put an _1 in there. All right. And then you use those, you go in and use the ball object to create a junction table. You set that first foreign key to be the employee. On this one, let's say we're setting up a relationship between mentors and mentees. So I'm going to make the first one employee, and in these parentheses, I'm going to say mentee. So I know that, let's say the first instance of that employee represents the mentee, and the second instance of that employee represents the that person's mentor. Okay, and so together I have now a relationship where I brought together the mentee and the mentor, and then I can have other information associated with it, like when did they start being in this mentorship relationship? When did they finish it? How many contact hours did they have when do this? This is actually something I built once for Spirit, where they wanted to start a mentoring program, and anybody can mentor anybody else depending on what you're doing. In fact, one of the things I would have put in here is the subject that they are mentoring about. But that basically, and again, remember I told you in the last video that your junction tables may have an alternate meaning. Here it's a junction between employee and employee, but it's to do mentoring. I could have said mentoring here if I want to, but I said mentor, and that's fine. Okay, you can always use the parentheses to give another kind of definition or description of what that table's about, or what a field's about, and that's what I did here in the parentheses. All right, so that brings those together now. But you got a situation right now where I could have the same employee could be both mentee and mentor. I have to constrain that a little bit. And maybe a person can mentor himself. I don't think so, okay? In most cases, I would think what you'd want to do is have a validation rule then. Again, this is a table validation rule. That's also true with the validation rule I showed you before on the recursive. This was a table validation rule on the employee table. So this would be another table validation rule that I could put on my employee table for this couplet. Oh, I'm sorry. This is actually on the junction table. I take that back. This is on the junction table. We don't want two records. We don't want the situation in the junction table record where the mentee and the mentor are the same thing. So I would just go in here and I would say the mentee, the value for the foreign key field that represents the mentee is not equal to the value of the foreign key field that represents the mentor. And then I would have this message on here. And now in that case, I can't have a mentee and mentor that are the same person. I would recommend you don't try to mess around with the lookup, to constrain it, because you would have to pick one of these and then refer to it first, And right now we can't control which one they actually pick first unless we actually did that in the form, where we have one active and the other one inactive, and then after one gets a value, we do the other one. It can be done. What I'm saying is it's a lot of work, and I don't expect it for this class. If you're building it out in the world, you might want to do that, and I'll actually show you how to do something called truth maintenance when we get toward the end of this class. That'll allow you to basically turn fields on and off based on whether other fields got values and what kind of values they got. So anyway, but that's something that's way ahead of us right now. So everything looks great. That would work wonderful. Again, on the Cascade update, you always want it on. I would think that you would probably want to have Cascade Delete. That's a good question. For this example, we elect to keep the Cascade Delete off, okay? And I think what we're saying there is we could have a situation where an employee goes away, but we want to still keep the mentorship record for that employee. So we'll probably want to keep them in the database no matter what. What I would probably do on this for the employee is have a field saying whether they're active or inactive, or a date when they left the company, but keep them as their record in there, and then I'll know. I could go here and know that that person has left the company, but at one time they were either a mentor or a mentee. But you may have a situation where you want to have the Cascade Delete on. In other words, if either one of these the records that are sending values to either one of these fields went away, then the record in the junction table goes away, and that's your prerogative. You could do that if you want to. Now, I do want to let you know that there is an issue in here, and I'll tell you something right now. I have been trying for over 20 years to figure out how to solve this problem without writing code for it, and I have never been able to come up with it. And I have talked to some people who are among the leaders in the field, and they think this is actually a problem in data normalizations that's never been solved. That there might actually be another normalization form that would be need to solve this. Okay, and that is the case where, say, I have a record for myself and maybe a record for my wife in this table. All right, and we're going to go into a mentor and mentee thing where she's the mentor and I'm the mentee. So I send my value here and I send her value there. And of course, we're making it look like it's coming from a different table, but it's really coming from the same table. All right. So I'm the mentee and she's the mentor. And that works fine. But let's say this was a relationship about friends. Okay. And in that situation, unless one friend was dominant, they're kind of on an equal basis. So I could have one friend and then another friend. There's nothing from keeping me from also doing the reverse. In other words, say I had Tom's record in there and Bill's record in there. I could have Tom as one friend, Bill as another, and there's nothing to keep me from having another record that has Bill and Tom, and Bill first and then Tom. Believe it or not, there's no way to handle that just from setting relationships. What you would have to do is you would have to do an exhaustive search to see, has the reverse ever happened, and then keep it from happening. You have to write code to do it, basically. To me, this is a shortcoming that should have been addressed through data normalization, and as far as I can tell, never has been. And I have challenged some of the leaders in the database field to tell me how to solve this without writing code, and they have told me they can't figure out how to do it either. All right. Now, the weird thing is, I know Facebook does this all the time. I know the social media sites do this all the time. Either they've solved it or they've come up with a program that can sort so quickly that it's a moot point. And I got a feeling it's the latter that they're doing, because you got to figure there are billions and billions and billions of people who could be friends with billions and billions and billions of other people, and which should make exponentially billions, trillions, quadrillions of combinations. And how do they go through all of those and figure out if the reverse has ever happened? And yet somehow they're doing it. So I don't know And if, often challenged my students, if anybody could ever figure that out and really solve the problem, I would really be tempted to give them an A for the semester. But it's difficult. I have thought about it. Every time I think I've got a solution, I realize it can't be done. In order for it to be able to work through normalization, there's two rules. It has to be done through relationships and or queries. Okay. And I have never been able to make it work in any combination of the two of them. I've always had to go out and do an exhaustive search in order to say that combination already exists. Don't allow the reverse to happen. So, anyway, and I perused the internet over and over to see if anybody else has ever solved it, and I've never been able to find it. So, but anyway, those are our two self relationships. Again, they don't happen often. If you go out and start practicing databases in the world, you will have them happen every now and then. I've got one right now where I'm trying to track documents where documents are related to other documents that are related to other documents, they're related to other documents, and it's a recursive relationship. I've also had this situation where I had, as I said, where I built a mentoring database, and I had to put this type of couplet relationship in there. And by the way, that reverse thing didn't really matter very much on on a mentoring one, because a person could be a mentor to a mentee, and it could be the opposite, that the other person could be a mentor and I could be, let me step back there. I could be a mentor and have a mentee, and then for another thing, my mentee could be my mentor and I could be their mentee. So it would be okay in some situations to have a reverse relationship. In other words, have two records that have this reversed, because we're doing it for different reasons. We're not doing it for the same reason. So I would have some kind of maybe reason thing, maybe a category relationship where I have reasons for doing the mentoring, and we would have a unique one then for our combination there. Conversely, I might also have multiple reasons that I mentor the same mentee. In that case, I could build a foreign key field on a category relationship and include it as in the alternate key on my junction table. So I wouldn't just have mentee and mentor in my alternate key. I would also have that reason that we're doing the mentoring. So it's pretty neat. It's got a lot of flexibility. You could do pretty amazing and powerful things with just sending a relationship. As I said, you could have a whole hierarchy. Uh, One student once asked me, once I've got that hierarchy built, though, is there a way for me to extract it? Very difficult to do in a query. Okay, you'd have to have a recursive query. What I usually do, because it's a lot faster, this is one of the few times I would absolutely go in and write some Visual Basic code and write a recursive function that brings back the first record and then finds all the other records on the next level from that record was referenced in, and then from each one of those go out and just keep doing it, go out recursively down one branch of the tree, then come back up, go another branch, back up, go another branch. And then when I'm out of branches at that level, go back to the next level, hit another branch, go on out, go up, and all that. And it's pretty amazing. I've done this. I did this once on a database that had something like, I want to say it had 2,700 branches basically in its tree, and it came out so nice and ordered. What I did too is I indented each one as I wrote it out, so I knew what level it was. But it was basically a printout of the whole thing. It wasn't anything that I could actually work with. I also have made these so I could actually work with them in a flat multi-record form, but that's extremely difficult to do, and I wouldn't expect you to do it. So, anyway, pretty neat relationship. If any of you guys want to try to use it on your projects, feel free. And if you do, let me know, okay? Because you may need some guidance, and I'm absolutely available to give guidance on this one because it is really above and beyond what I'm asking you to do in this class. But just know that those are two very special relationships. And at this point now, getting through LO5 and you haven't gotten through this reference, you have seen every relationship that exists that I know of anyway, except for the auxiliary relationship. And we'll see that again because it mainly comes into play for very special reasons. And one of the big reasons is because we might want to have a view of data across different subjects or even subjects and subsubjects and bring that back in a report where we could have things sorted on categories and then sorted within the other table. So we build a join, and the join will utilize auxiliary relationships in order to bring fields together that may or may not provide additional information for a record in a subject table. And again, I know you don't know what that means right now, but that's the nature of the auxiliary relationship. It can be very, 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 very powerful, but it's also something you don't use very much. Okay, but when you do, it's very helpful. So we'll see that on the next. We'll see that in the next lesson, lesson L06, L06. Thanks very much.